All right, so in today's video, we are going to be looking at the graphs of logs and exponential functions and looking at their key features. So first, if you're not given the graph of the function, we always need to graph the function, and we want to type it exactly like it shows us. To the x plus, oops. So this is something that can happen in Desmos. If it doesn't let you put the +4 in the exponent, you just put parentheses, and then you can do x plus 4 and close the parentheses, and it'll let you keep all of that in the exponent. So it's a little pro tip there. So after we get it graphed, now we can look for all the key features that we might need. So first, I'm going to look for the x-intercept and y-intercept. Remember, x-intercept is anywhere that it crosses the x-axis. I go and I'm looking. I don't think there's anywhere that this one's going to cross the x-axis. So instead of writing 0, I'm going to put none. Because if you put 0, it's going to make me think that you're telling me there's a x-intercept at 0. And then for our y-intercept, we can zoom, and it's actually way up here on our graph. So 0, 1, 62. I'm going to write it as an xy point. And the domain for all exponential functions like this is going to be all real numbers, so -infinity to infinity. But our range is going to change, and we'll come back to that one. Because we have to talk about vertical and horizontal asymptotes. If you remember from class, or you're just learning this for the first time, exponential functions never have vertical asymptotes. So we can go ahead and put none for that one. And asymptotes are just invisible lines that our graph or curve never crosses. So if it's a vertical asymptote, it's a vertical line. If it's a horizontal asymptote, it's a horizontal line. And it's like where our curve looks like it's getting really, really close to something, but it's never going to touch it or cross it. So every exponential function does have a horizontal asymptote. And if we look at our graph right here, we can see that it looks like it's getting really, really close to the line y equals 0, but it doesn't actually ever touch and cross it, no matter how far we go out to the side. So our horizontal asymptote is at y equals 0. The reason why I wanted to do the horizontal asymptote before the range is because the range and the horizontal asymptote are connected. So in this case, our range starts at 0 and goes to infinity, because range is talking about the y values. And if we look at where y equals 0, it never goes below that line, but our entire curve is above that line. And then the last thing we need to talk about is transformations. So we have two things that are kind of extra here or stand out. We have the 2 and the +4. So if you remember the notes in class, each of these had a different letter associated with it. And the letter associated with 2 is A. And when 2 is greater than 1, we call it a vertical stretch. So a vertical stretch by 2. And then the +4, so depending on what's in that exponent, whether it's plus or minus, it's going to either move our graph left or right. Since it's a plus, it's actually going to move our graph left. Forgot you guys don't like it when I write in cursive. So let's switch that. Left 4 units. Okay, so now we have talked about all of our key features for this graph. So we're going to do the same thing with the next one. We have a couple differences. So I'm going to go ahead and rewrite or regraph our equation. Okay. So when I match They look great. So let's go ahead and take a look at our curve. So first of all, I can see I actually do have some places where my curve crosses the x and y axis. So first, let's look at where it crosses the x-axis, which is the horizontal. So my x-intercept is going to be at 1.292, 0. And then our y-intercept is going to be at 0, 2.5, where it crosses the y-axis. Domain, same for all of them. So that's going to be all real numbers. And then we want to come back to the range after we do the horizontal asymptote. So there's no vertical asymptote. But we will have a horizontal one. So if we look back, okay, we can see it kind of levels out at this line, which is going to be y equals 3, because it's between 2 and 4. So you have a horizontal line at y equals 3. And then lastly, we have our range. So in this case, my range is going to be connected to 3, but when I look at my curve, before I start writing anything, I want to ask myself if my curve is below or above the line y equals 3. So in this case, it's below the line y equals 3 if I were to draw a dotted line there. So my range is going to be from negative infinity to 3 because it's 3 and everything below that. We definitely want to make sure we're using parentheses on these because it's not including that 3 or including that infinity sign. Okay, so now let's look at our transformations. We have a negative, which a negative should be like a big, I don't know, kind of red flag. Because anytime we have a negative, it's going to reflect over the x-axis. And then the 1/2 is in between 0 and 1, right? We take the absolute value of negative 1/2, which is 1/2, which is between 0 and 1. So that means this is a vertical compression. And then lastly, the number that's on the outside out here, that plus 3, that means it's going to move us up 3 units. So this one had 3 different transformations. And we always know the number of transformations based on like the extra things that are in our equation. Okay, so those are 2 exponential equations. And let's go ahead and take a look at some log equations. So again, I'm going to regraph over here. And remember, y is the same thing as f of x. So I can just put y equals. And when I graph a log, I'm going to want to hit the functions button and then scroll down to where it says log a, right? Because we have a different base. So in this case, we have log a of 5 and then x minus 2. Close parentheses. All right. So now we have the graph of the log. Remember that logs and exponential functions are inverses of one another. So they have a similar shape when we graph them. They just start and end at different endpoints. So let's start again with the ones we're more familiar with, the x-intercept and the y-intercept. So I see here I have an x-intercept at 3, 0. Where it crosses the x-axis. And then I don't see a y-intercept for this one. So just to double check, I'm going to zoom out. But again, I don't see anywhere where it crosses the x-axis. Or sorry, not the x-axis. Crosses the y-axis. So we would say none for our y-intercept. And then our domain is actually what's different for a log function. So we're going to come back to our domain, but our range is going to be all real numbers. Okay. And just like our range is all real numbers, the horizontal or the asymptotes switch. So log functions never have a horizontal asymptote. They only have a vertical asymptote. So a vertical line where our graph gets really close to but never touches. So if we look here, we see that it looks like it's getting really, really close to 2, but it's actually never going to touch 2. So we have a vertical asymptote at y equals 2. Sorry, not y equals 2, x equals 2. Because it's a vertical line. Okay, so we have our vertical asymptote, and like when you click on the line, it even tells you 2, undefined, which means that our asymptote there. And then let's look at our domain. So our domain is actually what changes. And again, it's connected to the vertical asymptote. So starts at 2. And then if we look at everything to the right of 2, that's where the rest of our curve goes. And the right is where all of the positive x values are. So our domain is going to be from 2 to infinity. If our curve had gone to the left, then that would be where all the negative x values are. So that would be where negative infinity is. And again, we want to look for any transformations. Remember that this b value is not a transformation, that b value right there. That's really just telling us about the function itself. So the only transformation we have is -2. And just like with our exponential functions, when the number is inside the log or inside the exponential or the exponent, it shifts opposite. So this -2 is going to tell us to go 2 units right. Okay. So that's all about our first log function. And we'll do one more example. So let me switch our graph up here. I'm going to show you again how to get to that log feature. So you want to go to functions, and you're going to scroll down until you see log. So I went too far. There we go. To log. And I actually didn't click the right one because I need to click log A. That different base. So log A, lets me type there, is 1 divided by 2. All right, let's just start over. See, Desmos can be a little finicky sometimes. All right, so log A. Inside my base, it's 1/2, so I do need to put parentheses around the 1/2 so that it stays in the base. If not, it'll try to separate it. And then I have x minus 1 and plus 4. So I want to make sure that my equations look the same, and they do. So let's see what we got going on here. And go ahead and see that I have one intercept here, and that's where it crosses our x-axis. So I have an x-intercept of 17, 0. And I don't see a y-intercept anywhere, so that's a none. Domain is the one we want to come back to when it comes to these. So the range is what's going to be all real numbers. And we know that there's no horizontal asymptote because it's a log function. So if we're looking for a place where there's a vertical line, that invisible vertical boundary, I see that right at x equals 1. If I were to draw a vertical line through x equals 1, my curve wouldn't cross it or touch it. So now when we look at our domain, we're going to kind of evaluate where it is by 1. So I start at 1, and then if I'm looking to the right or to the left of my curve, right or left of the line to see where my curve is. So here I see that my entire curve is to the right. So my domain would be from 1 to infinity. And then this one has a couple more transformations here. Oops, not the 1/2. the minus and the plus 4. So we said inside is opposite. So the minus 1 on the inside becomes a plus 1. So it moves 1 unit, right? Okay. And then the 4 on the outside moves it up or down. So we have 4 units down. Okay. So that's a quick overview of how we find the key features of logs and exponential functions. But really the key is using Desmos because they'll graph it for you and then you can just look for what you need to look for.